Hey and welcome, and in today's video we will see how RAG works, and we will be doing our first project in RAG, so related to RAG actually. So you must hear about it a lot. So what is exactly this RAG? So we will start with the really basic introduction of theory, and then we will implement it by coding by all means, and at the end of this video, you will have your one RAG project complete. So let's start. So what does RAG actually mean? So starting off, it means retrieval. So retrieval augmented generation. So what does that actually mean? Like, this means retrieval. So that means we are getting an information from some database. Okay. And generation means we are generating anything with Gen AI. So any LLM model or anything else, we will be generating them both. So if we add both of them, this is what actually RAG is, just a combination of these both. So maybe that is very burdenful for you, but now I will ease it up for you what exactly RAG is and how it works. Okay, just stick with me. Let's take an example of the project that we are going to do. So first of all, let's say I have a book. And I want to implement RAG on that book. Maybe that book is on a politics. Okay, so I will get the book on a politics. Okay, so now I want to implement RAG on it. How can I do that? First of all, I get the book, I download it. Okay, now I have a whole lot of text in that book. Very, very much of text. Okay, so first of all, what will be the first step of ours? The step one is going to convert this book into TXT, so it will understand better. Okay, once I done that, what will be the step two, and why would we do that? The step two is going to convert text into your chunks. All right, so what does that mean? You know that we have a heavy paragraphs of text in a book. What we are going to do is to take them into chunks. Let's say, okay, 3 lines of text, or maybe we'll say 50 words, create one chunk. Okay, so why are we actually doing chunk? Why do we need? We have a large corpus of data. Why we need actually the chunking? Let's answer this one. Because the data is too large and we need to store in the database. That's why we are doing chunking. And when we follow the next step, you will know why chunking is so important. So what's the step 3 is going to be? So the step 3 is going to convert each chunk into vector. Okay, that might be a new thing for it. And you can say, what is it? What is vectors? So let's say I have a sentence, I am a boy. Okay, now I'm going to store a numerical representation of this line. So that might look like 112, 112, 019, or something like this. This is a vector representation of how we get it. We will see how we are going to convert these words into actual vectors and why these are so important, because our computer only understands numerical data. All right, and then after converting each chunk into this kind of vector space, we store it. Where do we store it? We store it in our database. So what is this database? This database is actually consists of all chunks stored in, okay, sorry for that, database. So that will be like a large database, And there is first chunk, then second chunk, then third chunk, then fourth chunk. So this is actually my database, and it got a lots and lots of chunks stored in it, the whole book's chunks. Okay, what's the next step? I have done till now. What I did now, I get the book, convert it into chunks, then I convert these chunks into vectors, and then I store them in a database. Now, one new guy comes and questions me, what is Cold War? So this must be the answer inside my book. I have to go inside my book and search for it. But no, I don't need to do that. Now, I will convert this input by my user. This is an input. I will convert it into vector. So that might look like 009, 011, 03. This is just random numbers. You don't need to worry about what I put here. And if you want to know how vectorization is done, you have to refer to someone with the skipgram and these kind of videos that will teach the idea and tell you about that, how this vector space is done, because this is very important when we are talking about any LLM models. All right, let's assume you have a vector for now. This is your vector. Now, your program will take this vector and go into your database. Which database that this vector will go? This one, which have all the chunks written down there. This one, this DB, it will go there. And then it find out the similar chunks. It say, okay, I got 5 chunks from my database, which are similar to this chunk. All right, now I got 5 C, like 5 chunks. Now these 5 chunks, I will provide it to my LLM model. And that LLM model is going to generate a high definition answer for me. So this is how the whole RAG thing works. I'll summarize it to you. You now have a refined answer, but this refined answer is not only read by AI, but this is actually read your similarity does. Provides another chance to your LLM model, and then the LLM model works with the Gen AI to find answer. So in short, this is the whole RAG story. And now, in the future video, we are going to code it. And while we code it, that will be more clear to you. So don't overburden it. We will code step by step, and then we will see how it's done. So good luck. Stick with me to the next part. This is the PDF that we want to convert to our project. So this is our main PDF file. It has 192 pages. We want to just word it into our RAG bot and ask the questions to it. Okay. So you can go into it. I'll give you the link of this. But now, first of all, this is a PDF file. So we need to convert and extract its text out of this book. So let's first do that. The first step it's going to do is to extract our main text from the book. Okay, so for that I have created just a folder with the RAG project run. I will upload my PDF here. Okay, this is my PDF. Okay, so it's been uploaded now. I'll just create a new notebook so we can write all the code in it. It's been loading up. Okay, so here we go. All right, so to extract the text, we need to use a library which is called PineView PDF. And if you don't have it installed, you can just type it install PineView PDF, and that will do the job for you. Let it run for a while, let it give me the output. I have already installed it, so it's going to give me that requirement is already satisfied. Yeah, you can see that. So now, let's go on to the core functionality while we're using it. We need to extract the text from our PDF. Okay, so I'm going to say import, or what is this? I'm going to say FIPS. So what is FIPS? FIPS is actually a way to call this library. It's just a method of it, you can say, that will help us extract the text. So we can just define a function. We can say define extract text. And is that function, we will provide it with our book. And we could say, here we go, here's our book. And before implementing that function, we need to just take an input of our book. So for that, I'm just going to say our PDF is going to be my book name. And what is my book name? Actually, it's politics.pdf. So it's going to be politics.pdf. We'll need to put that in the quotations so we can pause it and it will read it from our home file. And now let's pass it to our functions. I'm going to say raw text, and that raw text is going to call our function extract text by providing it our name, which is PDF. And there we go. Now let's implement the core functionality of our function. So first of all, what it's going to do, it's going to open up our book, and to open up our book, we are going to use the fits. So we can say doc, and then you're going to use fits to need to open. And in that open, we are going to provide our PDF name, which is book here. So I'm just going to say book, and that book is being loaded here. And now we can create a variable which is called text. So this text variable is going to contain a whole text. So that's a great thing. Okay. Now we have to go over each page of our book and extract the text out of it. So for this, we just need to play by loop. So it's a for page in our doc. For each page in our doc, what you have to do is to say text plus equal to page.get text. So what it will do, it will iterate over each page and get the text out of each page. So you can see this loop. It will just iterate over each of the page and extract the data out of each page from data being text. And then it will simply return that, return text. And this is it, our function is being created. Let's run it, see for any errors. I just typed it with you, so maybe there is a chance for errors. No, there is no errors. Let's see what it returned us. So for check them, what it returned us, we need to write, like let's say a raw text. I could just say, give me the first 10,000 words, actually. So I can start my phone. Okay, so it will give me the first 10,000 characters. Hopefully, if I'm right, okay, I'll put semicolon there. That should be a colon. Let's run it. All right, so now you can see it really extracted the text. So this is our part one is done. The next part will be to convert it into the charts. So stay up with me. All right, so now what is going to be our next step? So we got the text. So you know that our next step is going to convert this whole thing into chunks. So let's do that. And what we have to do is that we have to convert them into the overlapping sets. I will let you know what we are doing, and it will be really easy to understand. So let's start. So we need a function. Let's create a function, which is, let's say, called split text. And it will take us few parameters. The first parameter is going to be our whole text. The next parameter is going to be our chunk size. So for now, I'm taking my chunk size to the 500. So if we don't provide it, it's going to take it to 500. All right. And then we have an overlap. So what is overlap? So don't worry about what overlap is. It's just a amount of characters that we need to overlap from the previous chunk. So when we write this function, you're going to know what this overlap is and how it's going to work. Okay. So first, let's call it. So the return will be the multiple chunks. So I'm going to say a variable which is called chunks, which say split text. And in that split text, what's I'm going to provide it? This thing. This is raw text here. This is what I'm going to provide it. So I'll just type raw text. And after that, let's say print out the first 4 chunks, what we will receive. That will be better. So I'll say chunks. This is small. Okay. So I'm just let's say for the first three. So I'll say, look, let's just print out the only first three, or maybe the first chunk of it. Yeah, so that's okay. Okay, so now coming back to the logic, what's the logic is going to be? So let's create a list which is called chunks. And that is going to be under here. We will append our chunks side by side, and we have to start from 0. Now, I'm going to write a loop here. And after I'm done with writing it, I'm going to explain it to you what's happening inside that loop. So stay with me, and then I can explain you. So I'd say, while start, it's going to be a length, it's going to be text. Okay, so we have to start until we find the length of text. So we have to just keep looping that until we reach its final length. So let's see. Now we have to do it overlapping stuff. I told you this overlap, like what this overlap actually means. For example, let's say that our first chunk is 500 characters. So our next chunk, the second chunk, is going to start from 400 to the next 500 characters. So it's going to be from 400 to 900. Then our third chunk will start from 800, and that will start from 800 to 1300. So the first 100 characters are going to be overlapped by the last chunk. So this is what we need to implement, and we can simply implement it using real basic logic here. So it's nothing to worry about. We're going to say start plus a chunk size, or we have to say the length is smaller than the text. Okay. This is just a logic of that thing. You don't need to worry about that. Just assume there will be multiple sides of logic. Some other guy will try to do it differently, but this is just a logic of your own. So don't need to worry about in the coding how I'm doing it. It's just my logic. So then I'm just going to append that chunk, this thing, into our text. So it's going to be text, the text which I got from. So it's start, and it went to the end. So the end we just find here, we created a chunk of it. It will start from the start, and that will end at that particular end. Now we need to update our start because we have already started. So our start is not 0 now. It's going to be start equal to, let's say, chunk size minus overlap. Chunk size minus overlap. So our chunk size is, for example, 500. And now our overlap is 100. So what's going to be stored in a 400 here is 400. So that means our next chunk start from 400. But you know that our first chunk exists of a 500. So that is why now you can understand the logic of it. This got the value 400 in it, but our first chunk is over 500. This is because of the overlapping. We need to do overlap. That is why we just subtract this overlap value from our chunk size to assign it to start. And we are pretty much done. We just need to keep going until we reach the length of the text, and that will do the job. Now, the only thing we have to do is just make a return call. That we're going to return the return chunks. That's it. And now 50% of the work, I'll say not 90% of the work of the chunking is done. Let's run that loop and see if there is any errors or something. We can check. Okay, so it's running. Let it run, let it run. It's just chunking up. Let's wait for it. Okay, so there was a little kernel issue. I don't know, I just restarted my kernel. And let's see if I run this code now, how much time it will take. I don't think that will take much time. But let's see. I just run with that cell. Let's wait now for it to run. Let's see how much time it's going to take. Okay, so there must be some issue with the kernel, so you don't need to worry about that. That was totally my issue on my side. So now, if I just run it, I didn't change it a single code of line, and it's work exactly same. So this is our first chunk, and we can tell this is just an open context of it. But what if we want to check the whole number of chunks? Yeah, I'm eating chips. So you should eat something too while doing the projects. That will be really good for you. And it will keep, even if you're stuck, it will keep you also entertained. So that will tell us how many chunks we actually have in our plot. Yes, you can see the number. We have 1, 2, 4, 8 chunks in our PDF. So now the next step will be to convert these chunks into our vector embeddings, and we will see that how easily that will be done. So the boarding, let's see the chunk number 69 or maybe 76. Yeah, there it is. There's the chunk, right? And if we saw 77, we should see the overlapping something like article arose part of the, yeah, you can see that the article arose the other part. So that means this is little overlapping of the things. So the chunk size will relate from project to project, but here 500 is more than enough and overlapping is 100 is good. So see you in the next step. All right then, so now what we're trying to do is to move on to step 3, and what step 3 is to actually convert our text into embeddings. So what does that mean? First of all, we just extract the text out of our PDF, and then we just break it down into the small overlapping chunks with 100 words are overlapping. So that is our second step. Now, what we want to do is to actually convert those chunks, which are actually stored in this, to a vector embedding. So what are vector embeddings? It's just a numerical representation of these words, of these chunks. So our computer will know which way to it have to find the similarity. So we just need to convert them into numerical embeddings because we know that the computer understands numerical data. So each of the chunk will be represented by a numerical array. All right. So let's try to do it. So for that, we will try to use a very small model, which is fast and pre-trained, and we don't have to train them on our own. We just use this model, which already know the context of the language. So it will provide us a fast embeddings and quickly. So let's import that one. So for that, I have to deform sentence transformer. I have to import a sentence transformer. Okay, let's run it. Perfectly fine. It runs itself. Okay, so now I have to import the model from this one, which I have to use to actually embed my textual data into numerical form. So I will say model. Then I just use the sentence transformer. And in those brackets, I have to provide them with a model. So there are multiple models that you can use for it, but I will recommend you to use that one that I'm using, which is small, lightweight, and fast. So quickly follow what I type in it. It's all, and it's mini LM L6. Hopefully it works. Once I run it, I need to check if I'm writing right or not. Let's run it. It's taking a second to extract the model. Let's wait. Okay, so that worked finally. So that means that our model is successfully loaded. Now we just need to embed our data, give it to this model, our chunks, and say it to them like, okay, now encode my data. So for that, I'm going to declare a variable which is called embeddings. And let's try to do that. Embeddings, and I'll say model.encode. And to that, I will provide it with a chunks. And which chunks? These chunks that we just did of our data. We divide our data into chunks. That chunks I'm going to provide it with. Okay, so here we go. The spellings are same. Yes, the spellings are same. Let's run it. And it ran perfectly fine. That means that our chunks are actually converted into embeddings. and then we can just quickly check it out. That may take a little time because we have a lot of chunks and each chunks need to convert it into embedding. So you can skip to 10 seconds or 20 seconds if you want to. All right, so our chunks are being created and you can see that our cell has been run and it is stored in our embeddings mostly. So let's try to output or break the embedding and actually see is our data stored or not. So I'll just embeddings and then let's take the first chunk and let me just print out like the first 5 numerical embeddings for the first chunk. So what I will type is to just say, I'll say just plus 5. So just have to do this. Perfect. So let's run it. Let's run it separately, I guess, so we don't have to run it again all the way. Embeddings, maybe I misspelled something. Yeah, it's embeddings actually. Okay, yeah, so this is our first chunk, and these are its vector representation, the embeddings, the numerical representation. So I just showed you the first 5 numbers, but it can be a lot. So this is done, and you can see now this, it's the vector embedding of our first chunk, and it is stored into the data. And now we need these embeddings to be stored in our database. So in next part, we will select a database and we will store it into that. And we have to do the vector database. So stay with me. This was a really small step. We just took out the textual data, give it to our model, which is all mini LM L6V2 model. And we say to convert it into numerical embeddings. It's a pre-trained model, so it doesn't bother us in the pre-trained. Okay, so our 3 steps are done. And let's see what's happened in the step 4. And now for the step 4, what we need to do is that we just created embeddings. Now we have to store it somewhere where we can do a similarity search. And for this, we have a very famous Facebook AI similarity search database, you can say, or vector database, you can say, where we can store and index our vectors, these embeddings, and then we can extract the similar vectors out of it very easily. So first of all, what we will try to do is to import this vector database, let's say, and then we will try to convert our embeddings into the form that will fit to save into them. So let's try to do that. And first of all, we just need to say import and Facebook AI similarity search, which is import files. And let's just import NumPy also because we will use it later. Let's run it. Perfectly fine. Both run very quickly. Now, what we need to do is to convert these embeddings that we already have, these embeddings, into NumPy array, because this is a format that we have to follow to store it in this database. So I'll say embedding matrix. And to that, I just have to say NumPy.array and give it to them my embeddings. Sorry for that. All right, and I think that will work. Okay, perfectly fine, that works. And now what we need to do is to tell the dimension that each embedding has some sort of that dimension. So let's fix that dimension for us. So I'll say dimension equal to embedding dot embedding matrix. First of all, we have to say, and then I'll just say shape, but of it, we have to save the first character. All right. Now, what's the next step? Here, we just told them the shape of our, you can say, matrix, like it's 4x4 or 3x3, like something like this. So don't overwhelm what shape is here, but understand the complete concept of what is happening globally. So here, we're just trying to store our embeddings into a similarity search database where we can extract a similar chunks from our database. Okay, and now what we need to do is to give them the index. So index is really important because similarity search is happening, and wherever search is happening, index is very important. And we are going to use index flat L2 And what is this thing is that it will use the Euclidean distance to measure how much distance or unsimilar our embeddings are. So let's try to do that. So I'll just declare a variable which is called index, and then I'll use my database that I just loaded, and I'll say index lat L2, and in that I have to give them the dimension that we just extract. Okay, so you know that the dimension, and let's run it. Perfectly fine, that runs up, and if I just print that dimension here, so you will have a better understanding. It's 384, so the vector of each chunk is 384 in the length. So this is what happened. And now we have just set the index for them. And now what we need to do is to set the index for the whole thing, like all the embedding matrix. Here we created. We just have to give them the index, and that index will just like show it up for us. So index.add, and we just have to provide them the embedding matrix that we have. Because in that matrix, we converted every over embedding, each embedding to NumPy array. So that is why now we have to give them all. First, we just give them the dimensions, which are 384. We say, okay, this is how long that each vector is going to be. And here are our vectors now. So that's fine. Let's save that, and let's see. Let's run it. Perfect. That runs up. We can just remove this. No, we can just keep this. And let's see how many total indexes it has created. So for that, what you have to do is to just say print, and I will say index.endTotal, and I think that will work. Yes, so it created 1,248 indexes for us. And for each indexes, we have a data stored in it. And if you can see how many chunks we actually had, we had 1,248 chunks. And this is the exact number of indexes that it has created for us. So in this part, shortly, what happened is that we have embeddings. We need to store it in a database where we can retrieve a similar vectors, which database can help us retrieve a similar vectors because we need to use the similar vectors in future. And we first convert them into NumPy arrays. We sell them. Okay, the dimensions of that vector will be 348. And then we just provide them with our embeddings. We say, okay, here is our embeddings. And you could just save them and index them in your quite AI database, which is Facebook AI similar search. All right, so this is the whole similar search step. Now, from the next step, we will see how we can actually extract the similar search from this database. We will give them some input, and we will see like how they're going to respond to our input. So stay with me for the next session. Hey, so now in the next step, what we are supposed to do is to search our database for our query. So let's just do it. We have created a database which contains the vectors. Now I'm just going to create a new cell. And in this cell, what I'm trying to do is to actually send a query to my database. And I will say, okay, give me some similar vectors to this one. So we can have those similar vectors, and those similar vectors will go to our generational model, and it will refine our answer. So the first step, the one step at a time, the next step is to find the database. And after finding up the database, see those similar chunks. Okay, so for that, let me just create a one variable, which I will say query. And let's say, I'll say, what are the causes? What are the causes of revolution? Something like this, something related to politics. I hope it's inside the book. I never read the book, but I hope this question may be related to that book. Okay, and now let's create a function. So that function result will be stored in results, let's say. And the function name can be anything. Let's say it's search. And that search will take our query and search out all the things. And for that, I will create a loop for I in range, for I in results, we can say. Results, and I must say like, I can just print out the chunk. Let's print out just I, Yes, yes. Let's just print out I, and to just separate it, we can just print out a one line below this one. So we know that our data is printing out one by one. All right, so now the main thing is to create a function, and to create that function of a similarity search. So how can we create a function of a similarity search? So I'll define a function def, and I'll say search. It takes two parameters. First one is the query, so I will refer it as this. And the next one is how many similar vectors it will provide us. So for now, I'm just setting it up for 3. So I'll say top, and I'll say top k equal to 3. So we can give this parameter to our function, but that's totally fine that we are setting it up for now and not providing it by user. All right, now let's get inside this function. Okay, so here, first of all, what we need to convert our query, this query into encoding, the model that we use to encode the data. You remember this model we use to create and encode our chunks of data? Now, same thing we have to do with the query, because our query is an English form and we need to convert it into numerical embedding. So what we need to do, I can say query vector, and just need to use the same model, nothing else. I'll say model.encode, and in that I'll just refer my query. Okay, that will do the job. And after that, now after converting it into numerical embedding, I need to give it to something. So I'll say distance. I'll tell you after writing this line what these are, and indices. And now what we are actually doing here is searching our database. We're using this search function. We provide them with our query, this query vector, and we provided us with this top k, and we tell us to search this in our database, which is this index, and give us the similar vectors. These are the indexes of those vectors. We will extract the actual text from these, and these are actually the distances between those vectors. So the minimum distances they will give us, and hopefully when this will run, everything, the indexes will be stored in this indices. So now, next step would be to store them in a result. So I will say result, and I will just write a same loop in just a one line. So it will be in the list. So I will say chunks. Because it will give me a chunks as a similar vectors, because we have stored them as a chunk. So it will see that which chunk is really similar, and it will give us the top 3 chunks. So I will say for I in indices 0, and I think that will do the job. Yeah, and then we just need to return the result. Okay, I guess this will work. First of all, we convert it into encoding. Then we saw their distances and get the indexes of this closest similar vectors, and then we store them in a results. And I think this query will work. So let's just run it and see. Will it take some time or not? Okay, we got an error. Not enough value to unpack. Okay, what's this error is? Okay, so the problem that we are checking out here is maybe they are said not enough value to unpack, expected 2, got 1, because we have to give our query as a list. So fixing them as a list will just do the trick, I guess. Yeah, it did. So, okay, here you can see that we have 3 similar chunks. This is the first one, the second one, the third one. So these are very similar chunks, and we have stored them in results. These are actually the answer of what are the causes of revolution. And now these chunks, we will provide it to a generational model in our next step, generative model, and that will do the job for us. It will refine our answer in what we want with respect to our database. So stay with me for the next step. All right, so now we are on our last part. This is like the last part that we need to solve. We got the similar vectors. We got 3 similar chunks of data. Now what we need to do is to just pass it to our generational model. For generational model, I will recommend you not to install them because they are too heavy for systems. So you may install it if you have a good compatible system. But for me, I'm working on a laptop without a graphic card. So for me, I will go for Grok. which will help me remotely work with my API keys. So I'll just paste some code here and don't worry about that. Okay. So in this code, I have my API key, which you can also use for now. And I'm just giving a request to Grok. So basically, this is just a structure code that you need to use. I'm just creating my API key as in key environment variable. And I just told them which endpoint you have to hit. So don't need to worry about that. And you can just copy paste that code if you want to. This is really simple. Or you can find it in their documentation. That's really fun. Now, we need to create a function. And that function is going to like generate the answer. Let's generate the answer. Okay, and that one will take our query for sure. And it will take our context chunk. And what are our context chunk? Are going to be the similar chunks that we will be finding and feeding it to our GenAI model. So now I'll say context. Our context is going to be, we need to join them. Our chunks, we need to join them. So for that, I'm going to use some character sequence, which is just like that. Or maybe I can use the quotations here. That will be better. Then I can use it again. Okay, and after that, I just use to join context. So why this is because we need to like merge them all into a one variable, which is called context. So it will have more context of what we're trying to generate with our own database. And now we need to define a prompt after that, or the prompt that will be automatically going to our model so that it will tell us, okay, they need to do that. And for that, I'm using the f string, and then f string, we can tell them like, you're a helpful model. You are a helpful model, and you need to provide answer. And we are using f string, so we can apply multiple things in it, and we can say to context. And for the context, we can actually give them the context. So like this, we will just say, here is the context. And after that, we have to give them the question. And the question is going to be the query. Of course, it's going to be the query that we will be getting it with that. So here we go, and we'll say query. All right. So now, literally, our prompt is being done. So you could just change it to your own. You are a helpful model, need to provide answer to context and question that. And I can just keep going on and to like, it's might be political view or theory. So I can just do that, and I can just keep doing that. So it will give me the answer somehow, and I just need to say that answer. So I'll just say again, I'll go with that answer. I'll just say here, I end my F6 string. And after that, I need to do one important thing. Actually give this prompt back to my generational model so it can apply these and give me back my answer. So for that, we need to do multiple things. And first of all, we have to say response. Now let's create response, and that response is going to be of the client of chat. So these are where you, like, whenever you will use an API, you will be doing these things. So don't worry about what is these. These are actually very similar for every models. And here we will be using Llama 3 8B because that's the small and that is very fast, and it just provides us what we need. So that is why. And let's compile it down. We say compilation dot create, and here we need to provide them which model that we are using, why we are using, like things like that. So for model, I am going to take Llama 3. I just need to read that. Wait, HB 8192. Okay, so that was the difficult name of that thing, but you can just copy paste it from here. Okay, and again, we have to say which messages that we have to send. And these are all the parameters that is defined inside this dictionary already. So we have to take care of any misspellings or anything because these are predefined models. So we have this parameters. So we have messages, and in that messages, we have to provide them with the role that who are we, and our role is going to be user. And we'll just say user. And the one more thing that we are going to apply is the context. So the content is actually our prompt that we just created. Just right here, this is our prompt. So for the content, I'll say that our prompt. All right. I think we are really close to what we wanted to do. And after that, here is the temperature. So the temperature is actually the generative behavior of it. We can even check it, change it. It's totally depend upon you, but make sure to just have it on 0.3 for now. So it's totally okay if you want to change it, but for me, it's okay to be 0.3 right now. You can change it and play with it, and there will be an answer which is stored in that response, and we need to just return that. So I'm going to say response. Let's make a return here first, not print. I'll say response dot choice 0, and that's going to be message content only because responses might get really more value. So I'll just say to give me the response back of only the message. So I don't need any headers or anything else. So that is why I just keeping it that way. Okay, so let's run it. Maybe, might be, we have many errors. Very possible. Yeah, here we go. First error comes in. Let's try it out. And what the error is saying, it's saying, okay, so that might be choices, I guess. That error was just like, we didn't indent it a bit because of our, maybe this Grammarly thing. Just pressed that one. So this is why. Okay, we need properly intended route. All right, now it's properly indented, I guess. Yeah, it's working great. Now we only need to execute it. And to execute it, we are going to do one more step, and that will be the final step. Or maybe we're going to give error because of our content. Oh, we messed up a bit, but that's totally fine. Sure, Grammarly didn't help. Oh, damn. Okay, so let's define our query here. So this will be our query that will be asking concepts of ideal state. Let's say that. And for top chunks, we also need to find top chunks. So for top chunks, we will do our search in our FAII database, which is Facebook vector, like similarity vector database. And for that, I'm sending my query. And I'm telling them to give me the top K value as 3. I can set anything, but I'm giving it 3. And even if I don't give any value, it will take as 3. So that's one way or another to find the text. Okay. And now I'm just going to say answer, and let's say generate. Once it's run, yeah, it's run. So I'll just rerun it. So make sure we are good. So basically, when we run the generate answer, only then it will work, and it will tell us if it's running correctly, or maybe we have many errors. Or okay, so basically, what's the thing that they're taking? Query. Okay, so this is our query, and what else we have to provide them? Yes, context chunks. So context chunks are actually top chunks. So here we provided them with our query, like this is what is politics concept of ideal state. It will check these top chunks and extract the 3 most similar chunks, and then it provided those chunks to our query. Our generational model, and then it will generate a refined result. So this is actually the whole agenda. This is actually the whole agenda of RAG. So let's print the answer. I don't know if this answer question is actually related to it or not, but let's just run it and see if there are any errors. There might be. There might be a lot of. Okay, here we go. Search, got an unexpected argument, top k equal to 3. That's not an unexpected. Maybe, oh, okay. Let's just remove it. I guess we have already defined that it will be 3. Chat has no object completion. Yeah, we messed up some spellings. Yes, bear it with me. I think that's the right one. Okay, let's run them again. Okay, one more error. Okay, so the completion is still wrong. What's the spelling of completion? Maybe it's completion. Not this. Maybe I was right. And this E was not here. Yeah, I was right. I'm just missing a S. And next time I'm gonna end this whole thing like this Grammarly thing. It's just bothering so much. Okay, here we go. And help have generate a random topic, ask a question, let us know, I'll just the best. Okay, so our model is actually working. And what we have to do is to ask him a question properly, and it will provide us the answer. So I hope it did provide us the answer, but it didn't. So let's ask him something else. I'll do my best to assist. So what is the final revolution or French Revolution? The next step here are some examples. No, so actually something is happening and our code is not going. Our query is actually not working here. Our query is not working. Why it's not working? So the next time we are going to debug it, all right? Okay, so the error that we are encountering actually is that our query, that is what is the French Revolution, is not being given to our LLM model, and it is not generating the responses with that tool. We can see that our response is being generated, but it is not according to our query. So the problem to debug it is when we run it. Let's wait for it to run it. Okay, again, it's saying that I'm happy to help. However, I don't see a prompt for you. So it doesn't see a prompt for us. And why? Because that prompt is not going to be in quotations. This is actually the prompt that we are giving. So I just unintentionally put it in quotations. And let's just rerun this cell. It is being rerun. And now let's run this cell. Okay, so now when I run this cell, now you can see an answer generated, and this is a law pattern that including French Revolution can be seen as a manifesto of Aristotle ideas, and that is the whole point of doing everything. So this is all the RAG model thing that we have done, and it's done now. So step by step, if you have any question, you can just text me, and I will try to answer right away. So good luck.